welcome to CEC lectures. I am Dr. Preeti Jagani from Department of Computer Science, Arabic College, University of Delhi. Presently we are learning the topic of database management systems, and in our previous lectures we were talking about the topic of indexes. And in indexes we have seen why this indexing is required, how many types of indexes are there, and we have also seen the utility of multi-level indexes. Our today's topic is somewhat we can say different from indexes, and that is about the query processing. So when we talk about query, the first thing which comes up in our mind is SQL. So that's fine. That's what the language of query processing, or that's what the language of querying a particular database or a relation, we can say perfectly okay. But when we talk about the term query processing, what is it? So query processing is actually not a single activity, but we can say it's a kind of range of activities which is involving in extracting the data from a database. So query, when we talk about, is actually all about taking the required, or accessing the required information which is available in the database, and it involves various activities which are there in order to take the complete information from the database, or access the complete information from the database. So query processing, when we are defining in a formal manner, we will say the range of activities involved in extracting the data from a database. Now what kind of activities I am talking about? So how this query processing is going to take place, we need to look into that. So first of all, when we talk about a simple query, that query is in a high level database language, for example let's say SQL query language. This is to be converted into some expressions that can be used at the physical level of the file system. Obviously your high level database languages cannot be used at the physical level in order to extract the information. Now also when we talk about taking the information from the database, a variety of query optimizing transformations will be required, and then the actual evaluation of queries will take place. So basically these are the activities which are required, which are there in order to do the translation of queries from high level database languages into the expressions to be executed at the physical level. Then we have some query optimizing transformation, and then we have the actual evaluation of queries. Now the question comes up, translation and actual evaluation is fine, but why do we need to optimize the queries here? Because I'll be taking this in a short while, but just to give you a flavor of this, that a query can be evaluated, or query can be we can say executed in many of the ways. It's not only the one way of execution of query. At one particular algorithm of execution of query, same query can be very expensive as compared to the other algorithm. So we need to also see, or we can say the system also needs to see which is the query, or which is the algorithm, or which is the technique which is going to give you the best results in an optimized manner. So definitely optimizing is requirement. So the steps involved in the processing of a query are basically three, as you can see here. One is parsing and translation, which I was talking about, taking a high level SQL query and translating into the statements which can be executed at the physical level. That's the first process in which your system is going to parse the SQL query, and then it is going to translate it. Then we have the next step as the optimization. As I have told you that there can be various algorithms of executing a single particular query can be executed in various ways. One can be costly in terms of resources, another way could be is having cheaper resources, or is using the resources in an optimized manner. So there the optimization is required, and finally we need to do the evaluation. So these are the steps involved in the processing of a query. Now Before, let us take all of them, in a step by step manner. So, before query processing is going to begin, the system is going to translate the query into a usable form. So, what usable form I am talking about, that can be used on a physical level in order to extract the data. So, for example, we generally write the queries in a high level database language, for example, standard query language, which is our SQL. That SQL is, very good, or we can say very suitable for human use, but it is ill suited, or it is not the appropriate representation of the systems, the way systems internally represents a query and the way SQL is representing a query. Those two ways are actually, you will see in a, in our upcoming slides, these two ways are actually, very different. So, a language such as SQL, which is suitable for human use, may not be, or it is actually not suited to the system's internal representation of the query. Now, the next thing is, a more useful internal representation will be one which is based on the extended relational algebra. So, please recall, we have also gone through this relational algebras when before going into the SQL things. So, first thing, your system, or the first action which your system is performing within that range of query processing activities is taking a given query and translating that query into a usable form, or we can say translating that query into an into its internal form. Now, this translation work is actually similar to the work which is done by the parser in case of a compiler. So, you understand, when a compiler is kind of compiling a particular program, it will take one statement and then, or it will take one chunk and then it will start kind of parsing that particular chunk. So, basically that is the thing which is done here in case of translation, and this work of translation is similar to the work of parser which is being performed in case of a compiler. And in order to generate that internal form of the query, the parser first going to check the syntax of the user's query, and this is what is actually the first step when we try to compile a particular program. So, if the syntax is not correct, then it is going to get some errors. So, similarly here, you can proceed only if you have the correct syntax. So, the parser checks the syntax of the query, that whether it is a correct syntax or it is kind of it is a syntax with some errors. Then it is also going to verify the relation names which are appearing in the query, and what are the relation names of what are the names of the relations available in the database. So, for example, we have written instructor. I am just giving you a very small example, and the spelling of instructor, let us say we have we have done a typo there, and we have written the instructor application of the instructor as wrong. So, what will happen? It is not going to match with the name of the relation instructor which is being stored in the database. So, at the time of generating the internal form of the query, the parser is going to check the syntax of the user's query. It will also verify the relation names appearing in the query, that they are same as the names which are a relation in the database, and so on and so forth, some other activities also. Then your system is going to construct a parse tree representation of the query. Then how this parse tree representation of the query is looks like. We will be taking a particular query and we will be seeing all these steps done on that. I'll be coming to that in a short while. After that, it is going to be translated into a relational algebra expression. As I have just told you that your SQL is not suited for the system's internal use, rather the relational algebra expressions are. So, after construction of that parse tree representation of the query, it is going to be translated into a relational algebra expression. And also, one very important thing which we need to take care here is, if the query is expressed in terms of a view, please recall we have made views also, and the queries are perfectly queries can run perfectly on the views also, or queries can be fired on the views also. The translation phase, if it is about a view, the translation phase also replaces all the uses of views by the relational algebra expression that defines the view, because view name directly there is not going to be kind of found in the database, because these are kind of abstract. So the names of the views or the query which is expressed in terms of the views, the translation phase, that it replaces all the uses of view by the relational algebra expression which is defining that particular view, and this is very important here. So as you can see on the screen, this particular figure is actually giving you an insight into what all steps are there in order to execute a particular query or in order to process a particular query, and we will be seeing all these. So starting from the query thing, so first of all the query comes up, then the next step, as you can see, is about a parser and the translator. So it is being parsed and translated at the first step. After this parsing and translation, the corresponding relational algebra expression is being generated. After generation of this relational algebra expression, the query is being optimized. Now what is the meaning of optimization in terms of query? I'll be coming to that in a short while, along with an concrete example I'll be taking. Then an execution plan is basically formulated, we can say. Now this we can say a modified form of your query is given to an evaluation engine which is having the access to the data, or which is having the access to the database, and finally the output of the query is generated when your evaluation engine is going to take the data from the database. So one step, as you can observe in this figure, is this optimizer is getting some input from your statistics about the data. So let us say there are two algorithms to execute a particular query, and your optimizer is going to get a feedback, or it is going to get an input from the metadata, or we can say whatever the statistics, not the real data, but the statistics about the data which is available there. So what what statistics about the data I am talking about? So let us say how many rows are there, and is there any index onto that, what kind of index is that, and so on and so forth. So your optimizer is in the need of all this information, because the task of the optimizer is to pick one algorithm which is cheapest in terms of resources, and through that algorithm we are going to have the result of the query in its best possible form. So query, after being parsed and translated, it is going to be converted into a relational algebra expression, and then it is going to take an input from the statistics which is available about the data. Your optimizer is going to take these input, and on the basis of that input your optimizer is going to choose one particular plan through which your query will be executed. That execution plan has been chosen or formulated, we can say, and then it is finally given to the evaluation engine, and your evaluation engine, after taking data from the database, is going to give you the output of the query. So this is what your kind of, we can say, whole step or all the activities which are involved in the query processing goes like in this manner. So a variety of methods are included when we are talking about the term query processing. So first of all, the SQL query, as I have told you, can be expressed in several different ways, and each SQL query can itself be translated into a relational algebra expression in one of the several ways. So what I am trying to establish here is there are many ways in which your SQL query is going to be translated into a relational algebra expression, and that relational algebra representation of the query specifies how to evaluate a query, but only partially. There are several ways to evaluate the relational algebra expression. So, in order to understand this concept, let us take an example which is about a query which says select salary from the instructor where salary is less than 75,000. Now, we want to as the first step of the query processing, we want to translate this query into relational algebra expression. Now, what all relational algebra expressions can be there for this? So, as you can see on the screen, there can be two variations to the relational algebra expression. So, you understand here the symbol of pi is about the projection, that is taking out of a particular column or accessing a particular column on the database, and sigma gives you which is given which is something related to the where, which is evaluation of an expression. So, here the first plan or the first relational algebra, here are the two relational algebra expressions given. So, the first relational algebra expression says you need to take out the salary of the instructor first, that means the first you need to pick out that column first. So, the projection and then the selection, or another idea could be the selection first and then followed by the projection. So, there are two different relational algebra expressions. One says we are going to pick that particular column, and within that particular column we are going to look for the salary figure which is less than 75,000. Another way or another relational algebra expression says you look for the salary less than 75,000 first onto that instructor relation, that means onto all the tuples, and then from all those tuples which are kind of we can say satisfying the constraint or the we can say where statement or selection criteria of salary less than 75,000, and then from those tuples we will be picking only the salary we can say the salary field or the salary attribute simple. So, attribute first then the selection, or the selection first and then taking up the attribute. So, this simple query, this is a very simple query if you can see. This can be translated into two relational algebra expressions, and in order to specify fully how to evaluate a query, we need not only to provide the relational algebra expression, but we need to annotate it with the instructions specifying how to evaluate each operation. So, for example, we have two operations here, one is a selection and another one is the projection, and your annotations may also state the algorithms to be used. So, for a specific operation or a particular expression which we are going to use, that can be annotated into that particular relational algebra expression, and a relational algebra operation which is being annotated with instructions and those instructions are about how to evaluate that particular relational algebra expression. That annotation is called, or that is called, an evaluation primitive, and a sequence of primitive operations that can be used to evaluate a query is a query execution plan, or we can say a query evaluation plan. In order to understand this concept fully, let us take a look on the figure which is given on the screen. So, here you have taken a projection on the salary state on the salary field or on the attribute of the salary. Then from that we are going to select all those values of the salary which are less than 75,000, and here we have written, or the system is given us a information that we need to use the index 1, and then finally this all is being done on the relation instructor. So what is this use index 1? This use index 1 is actually a kind of annotation. That means this is what I was talking about, that your conversion of an relational algebra, conversion of an SQL into an relational algebra expression may involve use of some annotations which are going to help us in in order to check out that how to evaluate that particular query, and these are known as evaluation primitive, and a sequence of these primitive operations that can be used to evaluate a query is what we include, or is what we call is a query execution plan or a query evaluation plan. So, the query execution engine is going to take the query evaluation plan, and that we have seen in our figure, in which we have seen all the steps that executes the plan and return the answer to the query. And you have seen one use of that evaluation primitive, which is which I have just shown you in the form of use index 1. Now, taking further from here, the different evaluations plan uh, for a given query can have different cost. Now, what cost I am talking about? Uh, but before this, one thing we need to make clear, that we are not expecting users to write their queries in the most optimized way, or this is not an expectation from the user that they should write their queries in a way that is going to suggest the most efficient, most optimized evaluation plan. No, it is not the responsibility of the user. It is actually the responsibility of the system to construct a query evaluation plan that minimizes the cost of query evaluation, and this is what the actual task of query optimizer is, and this is what you call is query optimization. So, query optimization says you need to construct multiple evaluation plans, and you will be choosing that particular evaluation plan which minimizes the cost of query evaluation. So, once the query plan is chosen, the query is evaluated with that particular plan, which is final, and the result of the query we are going to have in our output. Now, when we talk about the optimization of a query, we are talking about the cost of each operation. So, that means, that implies that in order to optimize a query optimizer must know the cost of each operation, because a query is going to be there with the help of many we can say operations. It is not just a single operation, as we have seen that in our previous query or in our example, that it is a combination of a select and a project operation on a high level, and definitely on a physical level it will translate into many more many more actions, many more operations. Now, what is happening here when we talk about the cost of operations? Exact cost, we can say, is actually not possible to compute, because it depends on the many parameters, your actual memory available, how many kind of page reads your operating system is performing, then how fast is your machine, and so on and so forth. So, it is not possible to evaluate the extra cost precisely, but yes, it is possible to get a rough estimate of the execution cost for each of the operation. And when we talk about for each of the operation, that means ultimately we are going to sum up the cost of each of the operation in order to have uh, the cost of one complete query evaluation. So, as we have seen that there can be multiple possibilities of evaluation plan when we talking about a particular query, and your optimizer needs to compare the alternatives in terms of the estimated cost and choose the best plan. So, in order to have this plan, the estimate of the cost of individual operations we need to, or your system needs to take out and combine them to get the cost of the query evaluation plan. And I mean, what is the unit of this cost of query evaluation plan? This is obviously not the unit as kind of we can say uh, rupees or something. That's not the cost of the parameter or the unit of the query evaluation, but your cost of query evaluation can be measured in terms of a number of different resources. For example, your query is looking into a disk access, your query is taking some CPU cycles, so CPU time which is there to execute a query, what are the disk accesses or how many disk accesses are going to be taken, and that too in a distributed system it is happening, or it is happening in a parallel database system, what is, and in such scenario what is the cost of the communication. So many kind of different resources are involved when we talk about one particular query execution, and these resources are it could be distributed or parallel systems, or cost of communication comes into the picture. Obviously CPU is there, which is giving some time, giving some cycles in order to execute a query, in order to take the data. It is also taking some disk accesses and so on and so forth. So in large database systems, when we see the cost to access the data from the disk is usually the most important cost, because that is something which is kind of an expensive part, because the disk accesses are slow as compared to the in memory operations. And moreover CPU, when we talk about the CPU speeds have been improving much faster than we have in our earlier systems. So what I am trying to establish here is, among all the resources, your disk activity time will dominate the total time to execute the query, and that is why we need to focus on the disk activity time. CPU time, when we talk about, is hard to estimate, or even it is harder to estimate because it depends on the low level details of the code execution and so on and so forth. But what we are going to focus on is actually the disk activity time, which is a major factor of your query cost. So in this lecture, in order to give you a summary of the lecture, we have started with the query processing. We have understood what actually query processing is, how many or what all activities are involved in this query processing. We can say what all steps are involved in this process of query completing or query execution, query processing. And then we have also seen how to how these costs can be measured, and we have taken a kind of, we can say, a macro idea about it. Inner level details we will be covering in our next upcoming lectures about this query processing also. Here is a list of references which is being used for the preparation of lecture. Hope you have enjoyed one. I will see you in the next lecture. Till then, take care. Goodbye.